Welcome to section 8.9, where we're going to represent a function with a power series. Now, one of the power series that we know a lot of information about is the geometric series. We know that the sum of a geometric series is a divided by 1 minus r. We know what that geometric series looks like. So any function that's in this general form, we would be able to represent it as a geometric series. Now, what makes the geometric series also so great, not only do we know the sum of that geometric series, but we also know the convergence of that series. We know that if r is, the absolute value of r is less than 1, we're going to converge. So we're going to be looking at functions that are in this general form and come up with the power series that would represent it. So just as a little example here, we've got a super easy example. We've got the function 1 over 1 minus x. Okay, it's super easy because it already resembles the sum of a geometric series. Notice we have the a is equal to 1, the r is going to be x. So I can rewrite it, okay, you've got that a times x to the n power. So we've got our 1 times x to the nth power. I know that this series is going to converge whenever absolute value of r is less than 1. Well, r is being played by x, so the absolute value of x. So you've got a radius of convergence of 1. You have an interval of convergence of this guy, okay? So the radius would be 1, the interval would be from -1 to +1. And since this is strictly less than, we know that those endpoints are not involved. Now this is the power series that is centered at 0, because you just have your x there. Now we talked about in section 8.8 when we are centered about 1 or about -1, and we're going to take a look at that as well. Okay, so if we look at this function f of x, okay, that's centered at 0. Well, I want to be centered, let's center at -1. Okay, so if we're centered at -1, that means I am going to need to replace this guy with x plus 1. Okay, well, I can't just go adding 1s in there because that is going to change my function. And actually, I'm going to be putting this in for the x. So when I add that 1, I'm actually doing a negative out in front. See that negative? So I've actually changed it by a -1. Well, if I change it by a -1, that means I need to add 1. Well, I don't want that 1 here. I'm going to put that 1 in front with this other 1 that's already there. Okay, so that means I'm going to actually have a function that looks like 1 divided by 2 minus x plus 1. Okay, so just to verify, this is exactly the same value as the original function. Because I have 2 minus x minus 1, that's the same as 1 minus x, okay? And then I really need it to be in the form of a divided by 1 minus r. So I really can't have this 2 here. So I'm going to divide everything by 2. I'm going to divide the top by 2. I'm going to divide everything by 2. So 2 divided by 2 is 1. And then I'm going to have x plus 1 divided by 2. So once again, I just divided this whole entire thing by 2. If you divide the top by 2 and the bottom by 2, well, 2 divided by 2 is 1. I haven't changed the value, but I sure have changed the look. Now I am in that perfect form. A over 1 minus r. So a will be played by 1/2. X will be played by x plus 1 over 2. Oops, sorry, r will be played by x plus 1 divided by 2. So when I go to write out my power series, I'm going to have a little n equals 0 to infinity, my a, which was 1/2, my r, which is x plus 1 divided by 2 to the nth power, and there's my power series that is going to represent this function, which I've garbaged all up with the red, this function that is centered at -1. Okay, so let's do a couple more examples just so we can see what the heck this is going to do here. Okay, so we are going to find a power series for this function that we have mentioned right here, centered at 0, and determine the interval of convergence. So we're going to try to get it to look like a divided by 1 minus r, and remember that 1 is very important. Once we do that, we know as long as the absolute value of r is less than 1, we've got ourselves magic. All right, so I need to somehow manipulate this. Notice I have 1 minus r. Oh, I don't have anything being minus. So we are going to change that. So I'm going to rewrite this as 2 minus a negative x. I know it seems like it's stretching, but I've still got the same exact thing. Now I'm centered at 0, which is a wonderful thing, because I don't have to add or subtract any numbers inside and then modify the denominator so it still is equivalent to x plus 2. So I'm ready to move on to the next step, which is to make sure I have that 1 right here. So I'm going to divide everything through by 2. So that's going to give me 2 over 1 minus a negative x over 2, divided the whole thing by 2. Now I am finally in that form. A is 2. R is going to be negative x divided by 2. So when I write my little power series, I have n equals 0. I'm going to infinity. Okay, I'm going to have my a first, so a times r to the nth power. So there's my power series. Now I've got to find that interval of convergence. Well, I know that r, if the absolute value of r is less than 1, I'm a winner. We're all winners, but you know what I mean. So I'm going to have the absolute value of negative x divided by 2, which is less than 1. Well, we know that the absolute value of negative x over 2 is the same thing as the absolute value of x over 2, so if you want to go ahead and do that, you can. Okay. So I want to go ahead and rewrite this now. I have my -1 x divided by 2, 1. I'm going to now multiply through by 2. So my interval of convergence is -2 to +2. And you want to put a little interval of convergence on that so people don't wonder what that random set of numbers is. We know that that is an interval and not a point. Okay? So you're looking at your function centered at, and you've got to get it into this beautiful form. Once you do that, it is all gravy. Okay, so let's try another. Well, I'm looking at this. I've got my function 1 over x, so that's easy enough. I need it to be centered at 1. So that means I need to have an x minus 1 in there somewhere. So let's take another look. Let's just write it out so we know what we're looking for. So I need to modify this. I need this to be an x minus 1. Well, I just had an x here, so if I subtract 1, then that means I need to add 1. Okay. Okay, so I've got 1 plus my little guy there. Now, I could have put it behind, but remember what look we're trying to go for. Okay, so everything's looking pretty good. I have the same value of function because 1 plus x minus 1 is x. Well, I need to have that minus there, so we're going to do our little trick of minus a negative, which means I'm going to have my negative x plus 1. Okay, if you want to rewrite that as 1 minus x, that's perfectly fine. It's just all in what your preference is. I finally have it in that form. I've got my 1, I've got my minus, everything's looking good. I'm going to put my a down. A is going to be played by 1. R is going to be played by negative x plus 1, or if you'd rather, 1 minus x, potato, patata, whatever. Potato, patata, telescope, you know. Oh, mercy. So we've got n equals 0 to infinity. Our a was 1. And then I really kind of don't like that starting off on a negative note, so I'm probably going to just rewrite it like that. Okay. Now, if you don't want the 1 in there, you most definitely do not have to put that on there. I can understand if that makes you feel a little goofy. Okay. So there's my power series, and really either one's going to be perfectly fine. Okay. And then we're going to find that interval of convergence. Well, I know when the absolute value of r is less than or equal to 1, I'm going to be convergent. Okay. Now remember that when you're doing the absolute value of a number is exactly the same thing as the absolute value of its opposite. So this is actually the same thing as x minus 1. Okay. Either way, it's going to work. It just makes it a little bit easier if you go ahead and split your absolute value up now, add 1 to both sides, so you're going to get an interval going from 0 to 2. So all those fun little properties of absolute value that make our life so complete. Okay, so remember you've got your a is equal to the opposite of a. Okay, and remember if you have a number, you can split that apart. Okay, so a little bit of property review. Woohoo! All right, so let's do another one. Oh my goodness, this one's going to take some modification. So we're doing the same thing. We're finding a power series that represents centered at negative 2. Oh, the craziness. And we're also going to find the interval of convergence, because really, truly, why wouldn't you? All right, so the first thing we need to manipulate is we need to change that x to an x plus 2. Well, you need to ask yourself, how has that changed my problem? Well, because I added the 2 in here and you've got that negative on the outside, that's really negative x minus 2. So I just subtracted 2, so that means I need to add 2. Okay, so that's going to be 5 plus 2. So that new guy is going to be 7. It's important that we are changing the look of the function, but we are not changing the value. So if you add a 2 in here, remember everything you're adding inside the parentheses is being subtracted. So we subtracted 2, so we better add 2 to make everything nice and balanced. So now we're nicely balanced. I have a 7, unfortunately. I need to have a 1. Once again, eye on the prize. We need that 1. So we're going to divide everything through by 7. 7? Yes, 7. So now, believe it or not, we're in that perfect form. Who's going to play the part of A? Why, 4 sevenths. Who's going to play the part of R? Oh, if you said x plus 2 divided by 7, you are right. So let's write our power series. Here it comes. Okay, we start off with our 4 sevenths, and then we have our x plus 2 over 7 to the nth power. Now, if you want to, you've got a 7 on the bottom here, you've got a 7 on the bottom there. You can go ahead and combine those to make it look a little bit more attractive. For instance, if you wanted to write your 4x plus 2 to the nth power, And then this is 7 to the nth power times 7, so that would be 7 to the n plus 1. It truly does not matter to me which way you leave it. On a free response problem, it won't matter. On a multiple choice problem, they may give you either version, so do not be afraid if the bases are the same to combine those exponents. All right, now we've got to do that interval of convergence. So we know we are convergent when the absolute value of r is less than 1. So rewrite your absolute value and then solve. So we're going to multiply by 7 and subtract 2. So we get negative 9 and 5. So our interval of convergence is in between negative 9 and 5. So you have to admit, changing those into a power series, a geometric power series, geometric is so nice. It's easy to find that interval of convergence. You even know about your endpoints. It's a good thing. I will see you back in class.